Good morning. I am Dr.N.Prabha, Assistant Professor of Chemistry, A.D.M College for Women, Autonomous, Nagapattinam. Now, I am going to present some basic fundamental concepts of spectroscopy. First, we see what is meant by spectroscopy. Spectroscopy is a branch of science dealing with the study of interaction of electromagnetic radiation with matter, or it is a branch of science dealing with the study of interaction of matter with light. So, what are the characteristics of electromagnetic radiation? We see that electromagnetic radiation is a form of energy that is transmitted through the space with an enormous velocity. It is discrete packages of energy which are called as photons. Electromagnetic radiation requires no supporting medium, but other waves require supporting medium. Electromagnetic radiations have a dual nature. One is electrical component and another one is magnetic component. Both of them, electrical component and magnetic component, are perpendicular to each other. When in the electrical component and magnetic component oscillate in a plane perpendicular to each other and directly proportional to the radiation. Energy carried by the electromagnetic radiation is directly proportional to the frequency. When visible light is passed through the prism, it splits up to 7 colors that we know with GR, which corresponds to the definite wavelength, that is the dispersion. In the instruments which recorded the variations in velocity of radiation is known as the spectrometer. Two types of spectrometers, one is absorption spectrum and another one is emission spectrum. In absorption spectrum, an analytical technique which is concerned with the measurement of absorption of electromagnetic radiation. That UV visible spectroscopy, IR spectroscopy is the example for absorption spectroscopy. In emission spectrum, an analytical technique in which the emission is dispersed according to some property of the emission and the amount of dispersion is measured. Example, mass spectroscopy. In the arrangement of all types of electromagnetic radiation, in order to the increasing wavelength and the decreasing frequencies is known as complete electromagnetic radiation. Above the visible region is known as the infrared region and below the visible region is known as ultraviolet region. In the gamma rays carry high energy while radio waves are least energetic. In the microwave have larger wavelength and also used in a telephone transmission. For example, X-rays can pass through the glass or muscle tissues. So, that is the gamma rays. In the radio waves can pass through the air. So, that is the microwaves. And UV and IR radiation can bend by the reflection or diffraction in a prism. In a UV and visible region, it comes from 190 to 800 nanometer that changes in the electronic energy level within the molecule. Conjugated saturation, conjugation with non-bonding electrons and the extended of pi electron system is analyzed in the UV spectroscopy. In IR spectroscopy, we can observe changes in the vibrational and the rotational movement of the molecules. Deduction of all functional group, it falls on 667 to 4000 centimeter inverse. In the microwave region or for IR spectra region, possible transitions are only in the rotational energy level. To obtain accurate data of moment of inertia, bond length and bond angle. In the radio frequency range, that is the NMR, nuclear magnetic resonance spectroscopy, is detected, induces changes in the magnetic properties of certain atomic nuclei, notable that the hydrogen counted and analyzed for the structure determination. In the radio frequency region, that falls for 60 to 300 MHz. In electron beam impact, that is 700 electron volt, that the molecules ionization and fragmentation is determined. Thank you.